So what I want to talk about is a bit how we at DDN look at the future of storage and what we are doing today. So years ago, we sat down and sort of discussed with end users, said, what's going to happen in a few years from now? What are the key challenges in the HPC data center? So one area that we looked at is flash. 5, 6, 7 years ago, that was this concept of burst buffers, and you would dump your memory to flash. But what has happened in the storage industry that today, enterprise storage, your laptop is all flash already. So we in HPC are a bit late to that party. We still use drives because a lot of the I/O kind of works with drives. But the reality is that if we look at our customer bases today, scratch storage is probably 15 to 20%. There is a lot of data analytics that is happening, life sciences, et cetera. The reality is that there is lots of small files, small I/Os in HPC as well. So we really think that this transition to flash in HPC, it's no more a question as, I have a use case for flash. It's something that will happen inevitably over the next 2-3 years for many, many reasons. One reason, of course, is that flash devices are becoming larger and cheaper. But also, as with any new technology, applications will start to adapt to those new capabilities. So today you have applications that run very well on a Lustre file system, but once you give an application the ability to do I/O in a much more powerful way to flash devices, the applications will adapt over time, and eventually we really truly believe that in a few years from now, all of your performance storage will no more be on drives, it will be on flash. So that's one of the key transformations that we see. And there are emerging applications like in situ analytics, where you run a job and you do analytics on your data immediately while you run a job, where flash becomes inevitable. The second area, which is a bit related, but broader than that, is that HPC used to be all about compute. It's still all about compute. So we come to these shows as a little storage vendor, or mid-sized storage vendor. And everybody talks about CPUs and sort of we are the little ugly cousin who... but the reality is that increasingly in HPC data centers, data really, really matters. And shuffling around data is a major issue and a major concern. So data-centric workflows really interact with applications today, and they will interact with applications even more in future. And of course, the notion of sort of a monolithic simulation has many years ago given way to ensemble simulations, or as I said earlier, most of our customers anyway, they don't do large-scale simulations, they do little tiny simulations. They run millions of jobs in a single day on various data sets in financial markets, in life sciences. So data application workflows in HPC are becoming much more data-centric. And the data sets are becoming larger, so you deal suddenly with petabytes of data. I remember years ago, customers said, I have this 5 petabytes on tape, and we calculated that getting it off tape will take us 5 years. And you're all aware of those issues. So data management in HPC has become absolutely crucial. So we have today customers that look at 100 petabyte storage systems. So imagine a 100 petabyte storage system. So data-centric workflows, data management at scale, I think is going to be a major topic for HPC data centers in the next few years. And add to that some of your data will no more be just on-premise. It will be in a cloud, a public cloud, a private cloud, a specific application cloud. So there is this one side where, yes, I have a capability with NVM to do much more with my storage. On the other side, I have to care about my data a lot more and where my data is. So we see these as the two key challenges in high-performance computing. So the transition to NVM-based storage This year, suddenly SSDs have become enormously expensive because there is a shortage in the market. One reason for that is that all the fabs of the suppliers, mostly in Korea and Japan, are transitioning to three-dimensional flash, and that transition isn't going as fast and as well, and the yields are not quite where they are. But the effect of that is, of course, that in 1 or 2 years, I will have flash devices that have capacities that are in tens of terabytes. And yes, the cost of those devices will become less and less expensive. And there is innovation in the market with things like byte addressable and VRAM that is coming. So we have seen Intel with 3D cost point. Yes, it's delayed, but it will come. So there's a whole new world of devices out there that is emerging, and that will eventually allow storage technologies to address a much broader market. But that said, those devices are also more complex. A drive is a drive, and writing to a drive from manufacturer A is more or less the same as writing to a drive to manufacturer B. It's not quite the same, but it's more or less the same. But writing to an SSD from manufacturer A can be very, very different than writing to an SSD from manufacturer B. The way how those controllers work, the I/O scenarios that the manufacturer builds into the device are very, very different. So the way how a storage system interacts with those devices also needs to be different. So it can no longer be just a local Linux file system. It needs to be a storage device that understands that underlying controller, that interacts with that controller to make the best out of that. So we have, in a few years, built a system that we call IME, that we have showcased at Supercomputing for probably 2 years now, if not 3 years. So finally, this is a system that is going into production at a number of sites. It's a system where we can, in a rack, deliver about 500 gigabytes per second of read or write performance. But we can also do on the order of 5 to 50 million IOPS from the same environment. Imagine in a year or 2 years from now, with higher capacity devices and even denser controller technology, we will be able to deliver a terabyte per second in a single rack. So here are some performance data from a 14K IME system with 20 nodes. So we can do about 500 gigabytes per second in read and write. And the read characteristics and the write characteristics are a bit different. This is, by the way, it's POSIX I/O. We also have an MPI I/O interface, and we'll talk a lot more about this later. But as you can see, we can also do 55 million write IOPS and on the order of almost 10 million read IOPS from the same environment. I can scale this down and now build a system where I take in a rack, a GS7K system, and I add to that GS7K system a bunch of IME to 40 nodes, and suddenly I get in 18 rack units a petabyte at 100 gigabytes per second performance. Transparent, because any data I write in IME is data that has metadata in the parallel file system. I can scale it up to 3 petabytes in a rack, 200 gigabytes a second. And these are not extremely expensive systems. We try to use relatively inexpensive SSD devices, so they're not prohibitive. They're more expensive than a drive system. But what I can do now, I can take my capacity. I can use high capacity drives. I can use 8 terabyte, 10 terabyte, soon 16, 18 terabyte drives. And I can use inexpensive NVMe or serial ATA SSDs to build a really fast performance tier in a relatively small form factor. So we see this technology not just as something that's a burst buffer for gigantic exascale systems. We see it as a technology that will become available and will be available in any HPC data center in the next 2-3 years. So this is something we can build and sell today. And as I said, we will talk more about this later. Now, our vision for the future here, so we have built IME as a cache layer. Our vision for the future is to take IME really to something that is very, very different. So we want to build data services on top of IME. And what I mean by data services is all sorts of data services, from block services to object services to file services, or even columnar databases. And we want to build that on the same environment. We want to do it in a way where service provisioning is automated with RESTful APIs, for example. So you run a job, you spin up a file system for a job, and you spin it down when you're done with your job and have trained your data back to a parallel file system. And as I said, we want all of that transparently managed. So the reality of your storage system becomes sort of a web-scale cluster with a bunch of nodes, from a few nodes to thousands of nodes, potentially, build up with a software layer, build up from the ground for NVMe devices, software layer that really interfaces with those devices, and that is optimized for specific off-the-shelf hardware configurations, but it's really a software-defined storage system that's scalable for SSD devices. So this is no more just a burst buffer where I dump memory once every hour or so because I run a large simulation, but we want to build a storage system that is a scalable storage layer that sits on NVMe devices. And yes, we want to interface that with a data management layer that links back to an object environment, no more parallel file system, on-premise or in a cloud environment that has optimized optimizations and automation for placement of data across various data tiers and plugins for sort of our data management environment. So it's no more just a burst buffer, but it's really a software layer that delivers various types of data services in an HPC data center and potentially beyond an HPC data center. You have all seen this slide, and we have talked a lot about end-to-end and data management. The reality is that in real life, as I said, we see more and more data workflows and data management problems, and those include data lifecycle management, so managing data across storage tiers, managing data from a POSIX file to an S3 object, from fast to slow media, from on-premise to public cloud. But beyond that, there are many data-centric workflows in an HPC data center, from ingest to distribution to collaboration, that all have their very specific problems. We see, for example, large-scale data replication and backup. Everybody does it in his or own way. But it is a problem that at scale hasn't been really solved by anybody from a vendor perspective. So we want to be a vendor who really works with you to solve those problems. And all of that, of course, needs to be either policy-driven or user-managed. So we want to give you the power to use both approaches. And then beyond just managing data, there is, of course, managing metadata. So when we store data, we want to store a bit more than just data. We want to know what this data is about, where it comes from, who has used it, who has accessed it. And eventually we want all that to interface with REST APIs into a data management environment. So in the way we look at sort of future development, we have outlined 5 areas that we're really looking at. So there is IME and sort of the next generation of NVM-based scalable software-defined storage. And we have a very aggressive development plan for the next years that we will start to share a bit this year, but you will see sort of the reality of that in the next 2-3 years. And we believe that really will become sort of a next generation platform for high-performance computing and enterprise big data. Secondly, there is our 14K SFA platform, where we're introducing next year a new declustered RAID approach with tiled-in redundancy that will give us a very different way to look at sort of a RAID device. This will be available by the middle of next year. And we have listened to customers, and we have really spent a lot of time on RAS features and RAS enhancements. So we have a first release called BOVA that is coming out in the next weeks that will have things like online enclosure upgrades or processes for online enclosure upgrades and various other RAS enhancements. And we will then have a focus on an SSD-based approach where we will resync sort of the SFA from an SSD perspective, rather than just take a block device and that was built for hard drives and then put SSDs in it. We really want to spend some time and resync what SFA can do in an SSD world. And you will see the first results of that in the second half of next year. Then with our object store, we have really spent a lot of time the last weeks and months to resync fundamentally what we do here. And what you will see from us next year is a combined approach where the different layers that today we have a core layer and an access layer or various access layers, all of these will be merged together in a unified software-defined storage layer. We have a new erasure coding scheme that will give you on a single site an easy approach to scale capacity in a high available fashion at relatively low overheads. And we have a number of S3 enhancements from multi-site to various other enhancements, quotas, et cetera, that are coming in the next few months. Then I mentioned data management. So today we have little software layers that sit in between a parallel file system and an object layer. And what we will do is we will significantly enhance those and build a much different, much more powerful, scalable data management layer that will become available as a standalone software product. So not just something that's tied to a DDN parallel file system or a DDN WAS system, but we look at this as data management at scale, independent of what the underlying storage system really is, or whether it's from DDN or not. So this is an area that we will focus a lot on, and we will talk a bit about it at this event. And then finally, in parallel file systems, our focus always has been on listening to users. So later today, we'll present our version of a multi-level security implementation in Lustre. That's pretty exciting. So it combines a number of approaches from SE Linux to subdirectory mounts, as well as Linux containers to build levels of security into a file system. And we also have spent quite a bit of time to build very scalable monitoring and management capabilities. So the latest large-scale Lustre file system, which is a system that has a total of 176 OSSs, the provisioning of the Lustre layer took 16 minutes across those 176 servers. So those tools are available and they're scalable today. Now, I also want to introduce something that's a bit different. I said earlier, we have listened to our customers. We want customers to be more involved in what we do. And here are two areas. So one is around RAS features. So we have a lot more RAS features coming in the 14K. Some of those features will be limited to the 14K. Other features will be available across platforms. And we have already started to work with customers. So we have done a demo for our customers at NCI ANU. And we also will have a lot more alpha beta programs where we will provide selected customers with access to early code releases. And we'll ask you to be involved more in the way how we develop products. And there's a number of examples that I could discuss. At the booth, just briefly, we have an interesting demo around IME, and we'll talk a lot more about IME later today. We have a demo for multi-level security in Lustre, and we have the developers here, Sébastien Bouisson, who sits behind there. Maybe, Sébastien, you can stand up so everybody can. So if you have questions about that, here is the man. And then we have one demo, of course, being DDN about end-to-end across a variety of layers from WAS to tape. And with that, I'll end sort of the last boring vendor presentation, and we'll go back to user presentations and more interesting presentations. Any questions?